together a demo very quickly while he was speaking that includes Dojo, jQuery, MoodTools, Prototype, Backbone, underscore, just for, just to be safe, Ember.js and XJS as well. And what happens when you actually run this is that you can animate his head. Let me just, right. So what this is actually going to do is it will continue animating this faster and faster until it actually uses up all of the RAM in your computer and crashes Chrome. Okay, that was productive. Right. So on to my talk. That is the first of many sound effects for this talk, there to keep me awake. So welcome to Decoupling JavaScript versus the World. In this session, we're going to cover a number of different aspects to decoupling your JavaScript application architecture, particularly for single-page applications. We're also going to take a look at how to create more fault-tolerant modules so that your applications can continue working even if particular parts of your page don't. At the end of this talk, following in the tradition of all the other talks, I'm also going to show you a new library. I've developed a new layer on top of backbone.js that helps you create scalable applications using their architecture and a combination of other design patterns, which I hope you'll be excited about. Some very quick information about me before we get started. I work at Google as a developer programs engineer. When I tell most people that I work at Google, they imagine that most of my days are spent doing this. Unfortunately, most of my days are actually spent doing this. In case anyone was wondering, I am in fact the man that's going away from the shark and not the shark itself. I'm kidding, of course, I do love Google. Our legal department did not in any way make me put the slide in, just in case you're wondering. I love writing. In my spare time, I enjoy blogging quite a lot about JavaScript, and I hope that some of it's come in useful for anyone that's read it. I released 2 open source books in the past year, one on developing backbone applications and the other on writing JavaScript design patterns. And luckily, both of them are now going to be released via O'Reilly this year as well. When I tell people that I'm going to be a published author, they imagine that the quality of the content I'm writing is quite a lot like this, something like a masterpiece. I feel sad because the reality is it's more like this. A horrific monster. Okay, and I've contributed to projects like jQuery and Modernizer and other bullshit. So decoupling. How many people in this room know what decoupling is? I know that we've got a ton of JavaScript developers. I'm saying about 50% of the room know what decoupling is. So for the other 50%, we're going to cover it very quickly. Now, the dictionary defines decoupling as the process of separating joined or coupled subsystems, enabling them to exist and operate separately. That's cool. Now, I thought, this is going to be a technical talk, but rather than explaining to you decoupling applied to software engineering and JavaScript, I would explain it through the medium of Kim Kardashian instead. So, coupling is a bad idea. Coupling with Kim Kardashian is a particularly bad idea. Coupling is this idea of maintaining direct links between different parts of your project or your application or your modules, really. And it's bad for a number of reasons. Imagine wanting to reuse some of your existing code base on another project and finding thousands of different direct references to code that you've written over the past year and having to spend another couple of months actually extracting functionality out of it that you could have easily gotten for free if you developed it in a slightly more decoupled fashion, where components were perhaps a little bit more independently kept separate. Decoupling is a little more awesome than coupling. Now, I like decoupling because in addition to allowing us to maximize the reuse of the code that we write, it also means that we can, depending on how you implement it, use design patterns like the observer to do things like, instead of directly telling other parts of our application what to do next, just being able to broadcast the application something interesting has happened and then reacting on that information, meaning that you could have potentially thousands of subscribers or people reacting to a single event rather than having that single event have to deal with all of that other bullshit. Okay, so I think decoupling is amazing, and I'm going to talk about a few different aspects to it quite soon. Another company that likes decoupling quite a lot is Google. Now, I think last week, a number of you tweeted me and emailed me asking me to find out a little bit more about how Google architects its applications, in particular Gmail, and Google Docs. I haven't been at Google a very long time, and so there was a limited amount of information that people were willing to tell me. However, I did find out some stuff, so I'm going to share those. Google loves using the MVP pattern. MVP stands for Model View Presenter, and it's a lot like MVC, except that you essentially have a presentation layer, you have an exact presentation layer, and a decouple layer for the logic. Now, they love using this pattern because it means that you can have one team focusing on the presentation, another team focusing on the logic behind it. And this decoupled development means that you're not waiting on other teams all the time to finish up their work because it's so tightly integrated with yours. And that's something that was used when building Google Docs. Another thing Google kept in mind when building some of their first applications that are quite popular today is this idea of applications being able to exist both independently and within other applications as widgets, for example. Now, one thing that you may have noticed if you've been using Google applications quite a lot, I assume everyone here has a Gmail account at least, right? How many people here have a Gmail account or use Google services? Everybody. Awesome. Right, so something you've probably noticed is when you persist across different Google applications, there are some features that are always there. Chat, for example. Chat is something that you'll find in Google Docs, you'll find it, or Google Drive now, you'll find it in Google Docs, you'll find it in Gmail, you'll find it in Google+, and they don't re-implement that every single time they're launching a new service, because that feature has already been done properly. It was created in a way that it could be easily reused with other applications, regardless of the frameworks that those applications are using themselves. And so you're able to take that, easily restyle it or easily extend it as much as you want, and then you don't have to go and re-implement that exact same functionality all over again. This is from another Google project, one that I'm not allowed to tell you the name of, but they developed with this idea of many people being able to work in a code base without being limited by dependencies. Now again, this is similar to the ideas that I just shared, in that they like being able to develop things without being restricted by one team being very, very dependent on the modules being developed by another team. Instead, if each team is working on specific functionality that can exist on their own, you can then easily glue those things together using an interim layer later on and reshare them across different projects. Google is also quite interested in this idea of deferred JavaScript loading. So rather than bootstrapping everything to your project when you load it up at the beginning of the user session, so perhaps loading up a meg of your entire JavaScript application, just loading up the most common features the user is going to be using, and then later loading in some things if they actually need them. I'm going to show you an example of this. This is something that was used in Google Docs, and it was used in the older version of Gmail. So if I take you to docs.google.com, and I go to Developer Tools, please ignore this internal stuff, create presentation. All right, just a second. Okay, so everything you see at the moment is considered the most common functionality that most users are going to be using. And it's still loading stuff. Okay, it's done. Now, let's talk about the other stuff on this page. Let's say someone is interested in equation editing, which is not going to be everyone. There might be maybe 10% of the population that are going to be involved in the sciences and math and are going to be interested in using the equation editor. So rather than loading this all in the Bootstrap, you can just do insert equation and then pull in the scripts needed for this later on. Now, where is that script? I believe it's this. Now, obviously, it's going to be completely compressed, etc. But this is all the code that powers this feature here, the equation bar. And it was dynamically pulled in. This is extremely easy to implement using a script loader like require.js. And if you're looking for information on how to do that, I think I cover it in my book on design patterns as well. Let's go back. So we seem to like decoupling, and it's a pretty cool concept. In case anyone was wondering what we actually use to develop our applications, there are internal sort of driven projects that we use. So Gmail and Calendar are developed using Google Closure. AdWords and AdSense are developed using Google Web Toolkit. And Google Drive is developed using a hybrid combination of Closure and Google Web Toolkit. Now, I'm a hardcore JavaScript developer, and some of that stuff is very much Java-based. Not to say it's bad. Some of it's really, really awesome, and I intend on spending more time learning about them. But I would like to be able to use some of these ideas that both Google and other large companies building complex applications have used in the past to work with my own stack. And I think you guys might like to be able to do that as well. So ask yourself, your current architecture probably is composed of something like this. You probably have modules, widgets, libraries, templates, and other bits and pieces. But does your current architecture allow you to do these things? Does it let you control the life cycle of your widgets? So are you able to completely stop a widget, deallocate the memory being used by it, and easily reload it later on if you need to? Are you able to have your application continue working if particular parts of your page fail? Not a lot of frameworks are allowed to let you do this stuff these days. Are you able to maximize the reusability of the components and the widgets that you write? And does your current architecture support allowing you to easily switch out the libraries you use without massive code rewrites later on? So let's say that a lot of us, we're JavaScript developers, we're going to be using templating, we're going to be using some DOM manipulation, probably going to be using some structural frameworks as well. What if we decide a year from now to change over and use something else? Technically speaking, it's a non-trivial amount of work in a lot of cases, unless you're working on a very small application. And having an architecture that already takes care of this for you or supports taking care of it can be useful. So I'm going to show you how to do all of these things. So I hope you said no to the last slides. Let's change that. So I'm first going to talk about decoupling a little more. So there are two sides to decoupling. There's component level decoupling and there's module level decoupling. Now, component level decoupling is interesting. Let's take, say, the spreadsheet component in Google Docs. Now it's composed of a number of more components that I'm showing on the screen at the moment. But let's, for argument's sake, say it's composed of a grid, charts, and a formula editor. If we focus on the grid, there's some specific functionality we can look at. So when you select a cell in that grid, you're actually able to autocomplete the text in that field based on other data that you've previously entered into the spreadsheet. So that's autocomplete. So far, it doesn't really sound that complicated. And if you implement that once, there's no reason why you shouldn't be able to use it on another project. Text formatting. What is that? Well, you're probably going to be applying some set of CSS rules to a piece of text and just making sure that it all displays correctly on screen. Again, nothing too much tied to the grid. And then you have search and filter, which, like autocomplete, really just requires you to plug in a data source and then do something in a callback when some results are returned. Again, we've got three components that we could easily reuse elsewhere. They don't have to be tied specifically to the grid. The only one that is tied to the grid is perhaps the table containing all of your columns and rows. Let's consider status update. So in Google+, we've got status update. Rather than having to go and re-implement autocomplete or text formatting, you can easily reuse the autocomplete component and the text formatting component. All you're doing is really extending the autocomplete to now display a list of friends that are formatted with CSS. And text formatting is just setting a different set of rules to the text formatter. It's now, everything that we're doing is now a little more reusable and it's saving us time. So it promotes reusability and less coupling means it's easier to reuse. Then we've got module level decoupling, right? We're going to give some design patterns some loving right now. Not this kind of love, because this kind of love is crazy. We're going to talk about the observer pattern for a moment. Now the observer pattern is interesting because it encourages this idea of perhaps the modules in your system, rather than directly communicating to each other, should instead perhaps not even know about each other. Maybe instead what they do is they just let the application know when something interesting happens. And then if anyone in the application is interested in reacting to that information, they can go and create a hook to that and execute behavior later on. It logically decouples objects generating events from those reacting to them. So let's take a look at some examples of this. And it's not really that complex, truth be told. Now, I'm not sure if everybody can see this. Let me bump up the text size a little bit. Right. So let's start off really, really simple. These are Jquery Deferreds, and basically what we're doing, so this is Jquery Deferreds, basically what we're doing is we're saying when our call to mail.php resolves, then we're going to do some stuff. We're going to display a dialog with a preview of the message that comes through. We're going to have an audio manager play a little sound that says a new message has come through, and we're going to increase the count of new messages in our title bar. I'd ask, why should the request care about this stuff? There could be 50 different things that I want to happen. 50, 60, 100 things that I want to happen when the request comes through. And the request shouldn't have to care about that stuff. Instead, what I could do is use pub sub for this instead. So I could easily subscribe to a topic, new message. And whenever request publishes on that channel and says, yes, there's a new message, here's the data for that new message, I can then react to that change. And I don't really like this idea of sort of keeping everything inside a single subscriber, so I can split it out so it's a little more organized. I can say, okay, well, here are the dialogue subscribers, here are the sound subscribers, and here are the miscellaneous subscribers. They're going to do something when a new message topic gets broadcast. Now, let's go beyond jQuery. So PubSub is found in a ton of different environments. There are a ton of different implementations available. If you're ever looking for like an afternoon project, write your own PubSub implementation. I did it, and I think it took me maybe 30 minutes. But I learned so much more about the pattern and how it works, and I came to appreciate it a lot more just by doing so. This is radio.js, and it's essentially another PubSub library, but it's quite nice. Again, you've got this idea of being able to subscribe to a topic, being able to broadcast data saying that something has happened, and you can unsubscribe. The nice thing about radio.js is that it actually also supports chaining. So you can say, okay, well, I've detected that a new message has been posted to that topic. I'm going to subscribe to that, and when that message comes through, I can then broadcast based on that, and I can unsubscribe. And I can easily chain these so I don't have to include them in the callbacks, which is kind of nice. PubSub exists everywhere. It exists in Node. You can have pretty much the exact same functionality here using a library like Fay. There are tons of others. So all I'm doing with Fay is I'm creating a new client, and then whenever someone hits the route/messages, I'm just subscribing to that, and then I can do something. Client.publish does the exact same thing as the client-side version of publish. And I'm not going to go through these, but there are so many other places where you can find PubSub. Backbone Events, for example, has the exact same concept where you can say on some event name, some topic name occurring, let's do something, and then trigger is essentially publish. And it's very, very easy. Backbone does have this nice thing of like allowing you to easily namespace the topics as well, so it might be worth checking that out. I think it's pretty cool. And the observer pattern is also baked into MVC and MVP and many of the other MV star variations that we're using today. So the way that models can be observed in that pattern, they're using a variation of PubSub. So let's talk about the facade pattern for a moment. Now the dictionary defines a facade as when we broadcast the rest of the world one thing, and that's not necessarily the complete truth. Maybe there's some additional complexity that we're hiding from the world. And what the pattern lets us do is it allows us to create beautiful abstracted APIs so that developers can easily work with these APIs rather than having to deal with all the complex implementations behind the scenes. To give you an idea, so it hides implementation level details. And here's an example of the facade pattern that we all use every day. The jQuery library, I would say 80% of the API that we expose in jQuery, so I'm on the jQuery team, 80% of the library that we expose is using the facade pattern. When you access CSS, animate, attributes, tons of other methods, it's all using the facade. We don't actually have to care about all of those detailed cross-browser normalization features behind the scenes, because this is just all we need to work, this is all we need to care about. It's very, very nice. So I'm going to show you implementation of the facade and then show you some code from jQuery source. So here's a very, very simple facade. I don't think you can see the entire thing. So this is essentially the module pattern, right? And the module pattern is composed of one private part and a public part. I really shouldn't have called that variable my privates. I apologize. Right. There are going to be too many innuendo jokes in this. Okay, right. So I have a section called my privates, and I expose to the rest of the world a public facade instead. And the rest of the world is supposed to interact with that. Now notice something. I'm going to show you a little one-line demo of how this actually works. So let me actually take this up. So this is how we interact with this particular module. We don't have to care about the getters, the setters, the jumps, or anything else inside that module, anything that the private parts have. All we care about is actually using the high-level interface that it gives us. So I'm just passing in some values, and then my facade is taking care of accessing my privates, which it shouldn't be doing, and doing whatever behavior behind the scenes it needs to. This is a really, really dumbed down example. But take a look at, say, jQuery. So we all use document ready. I assume, how many people here use jQuery? If it's not like 99% of the room, I'm going to be surprised. It's like 100% of the room. Excellent, right. So we all use document ready. The interesting thing about document ready is that the implementation for that is extremely complex. You will have people that will say, hey, here's a 5-line equivalent, and it really won't be. Here's actually our entire implementation. I started this project called Jquery Parts, just for learning, to extract out specific parts of the Jquery library, just to see, how crazy are the implementations. So this is essentially the code that powers document ready. I'm scrolling, I'm still scrolling. Dear God, I'm still scrolling. There, it finally ended. This is doing everything from making sure that Internet Explorer is able to handle document ready properly, to taking into account whether you're scrolling when you first start off the page. There's a lot of stuff in this, but we don't actually have to care about it because all we're given is that nice abstracted facade. And it's a nice thing to be able to use in your project, especially if you're working in multiple teams where you want to be able to let people use the code you've written without saying, hey, here's an API with 50,000 methods, because nobody wants to work with that. Next, we're going to talk about the mediator pattern. Now, I like to explain the mediator pattern in terms of an analogy, and that's air traffic control. So air traffic control has a centralized controller in it, very much like this controller in a marriage. Anyway, that one was pretty bad, I apologize. Anyway, so air traffic control. And the idea here is that we have a centralized tower that controls what planes can land and when they can land. This makes a lot of sense. Rather than having every single plane have to talk to every other plane to figure out what's going on, we just have one central point of communication. Could you imagine how terrible it would be if every plane had to ask every other plane whether it's okay to land? They'd all be fighting for who should go first. But that's essentially what the mediator pattern is about. You can think of it as a variation on PubSub. But the difference between the mediator pattern and PubSub is that the mediator is responsible for letting all of its, we refer to them as colleagues, but essentially subscribers, know that something interesting has happened. In PubSub, you have to have some sort of system that can keep track of all of your subscribers. And the mediator pattern just removes that need. It takes care of it instead. So it allows modules to broadcast or listen for notifications, and I've just gone through this with you. So let's take a look at some code. I'm not going to go into too much detail on this. This is essentially mediator.js by a guy called Jack Lawson, and it's a really, really great implementation of the mediator pattern. It's extremely detailed. You've got subscriber, you've got, let me try scrolling through this faster, subscribers, it's got channels. You're able to set the priority of different topics so that they first get, so when you broadcast, those topics are the first ones that have their subscribers notified about interesting events. But it's got an extremely rich API, and I've used it before. Sometimes you don't necessarily need everything it provides you with, but you're able to trim it down fairly easily. But it's effectively a lot like PubSub. So this is how we use it. So mediator.subscribe to the topic name. We can do as many of these as we want, and very similar to PubSub, we can just publish whatever data we want to those channels. We've got modules. Now, I'm not going to go into too much detail on modules, but we are in an interesting position in the community at the moment. We've got a ton of module formats. We've got AMD, so synchronous module definition. We've got CommonJS. Then we've got the classical module pattern and object literals. And people are sometimes torn about what to use. Because you use AMD and people will say, well, I don't necessarily like all the boilerplate code around it. I'm being rude. For anybody in the room that hasn't actually played around with AMD before or require.js, essentially this is what it looks like. So we have this idea of a define block. And I'm just saying define, passing in a list of dependencies, so underscore and backbone, and then I'm aliasing those so I can locally use them here. But that's not all. We then have the next version of JavaScript, which contains something called Es6 modules or Harmony modules. And unfortunately, the specs for those are still going through the standardization process. I'm trying to work with, how many people here have used or heard of Google Traceur before? So 5% of you probably. So Google Traceur is this really interesting project. It's a transpiler, which means that it allows you to actually write the next version of JavaScript in your browser, and it'll automatically compile it to code that works in the current browser. So if I pull up Traceur very, very quickly. So this is Traceur. running and connection works. Right, and let me just put in some ES6 compatible code. So basically what this does, which you can see lower down in the page, is it's compiling it to ES5/ES3, well, ES5 compatible JavaScript, which can run in the current browser. And this is interesting because it helps developers start learning the syntax needed for the next version of JavaScript today. I'm currently working with the Tracer team to try getting them to support the complete current version of the module specs and the module loader API, and they've basically told me patch welcome, but I'm going to keep on spamming them until they change their minds. However, it's interesting knowing about this stuff. There's another project which we'll probably be tweeting about in a couple of weeks that is trying to get in place a process where you can transpile ES6 modules to AMD. So you can write in the next version of JavaScript and have them compile down to AMD, which I think is pretty awesome. Anyway, let's move on. So let's brainstorm. We've taken a look at some of the ideas that Google likes using in its application architecture, and we've taken a look at the facade pattern, we've taken a look at AMD, we've taken a look at the Mediator pattern. What would be a really, really nice architecture based on these ideas? So something that's perhaps loosely coupled, that has maybe controllable independent widgets, and the flexibility to change. So if we wanted to change the libraries we're using later on, it's fairly easy and trivial for us to do that. If we're using widgets, if we're going to go with this idea of having blocks for a page be able to work on their own, as well as in other applications, we want those to be able to notify us when something interesting happens. We don't want them to touch anything outside of their own widget sandbox. They can communicate with the rest of the page, but we don't want them to directly touch each other. And we don't want anything we're doing to cause the rest of the application to crash where possible, which is a really nice feature. So the idea that I'm going to show you is a combination. Sound effect. Right. I'm going to show you Backbone Aura, which is a new layer on top of Backbone.js, which helps you build scalable applications. Okay, enough with the sound effect. Right. So there are 4 parts to Backbone Aura. There's an application core powered by the Mediator pattern. There's a sandbox powered by the Facade pattern, widgets, which are specific UI blocks, and modules, which are powered by Require.js 2.0, which has yet to be released, but it's sort of stable at the moment, and modules powered by AMD. So let me load this up. Right. So the application I'm going to be showing you is actually not that impressive to look at. Let me try downsizing this. But I'm going to try explaining this. So these are actually 3 separate applications being pulled in widget form. We've got a to-do application, we've got a calendar widget, and we have another widget which is just controls speaking to these other parts of the page. Just to make sure that this works, restart the page. Everything should still persist in the same way. Right, so persistence is working there. Now, let's go back. So the idea behind the application core is that you're able to manage the widget lifecycle. You're able to start a widget, stop it, and restart it if necessary. Let's take a look at this in code form. So here's our mediator. We're using AMD for all of our modules and pretty much a lot of the architecture. So it's got a subscribe as we would expect. It's got publish. This is where we start a module. And what you can see on the left-hand side is a list of our widgets. So we've got calendar, controls, and to-dos. And the way that we're loading these up is every single widget has its own main.js file containing all of its dependencies. And we simply pass in the name of the widget to load it up, which is fairly straightforward. So when I go back here, let's say I've stopped the widget. It's been completely removed from the DOM now. I'm going to explain this a little bit more in just a minute. I can start up the widget again, and it's just going to go and inject that entire widget, including all of the markup for it. There's no markup anywhere else in the application, just in each individual widget. And it's just going to work. And I can instantiate as many instances of this on the page as I want very easily. Stop is actually a lot more interesting. So in Require.js 2.0, we've got a number of interesting new features. One of them, which I've been asking for quite some time, is the idea of being able to unload or undefine a module, which is actually not that easy to do. And the idea is, if there's a particular module or script that we've loaded into our page, we want to be able to, if possible, deallocate the memory that's been assigned to that. And of course, obviously, remove all the references to that script as well from inside required.js's caches. In addition, we also need to be able to do things like clean up the DOM and any of the DOM elements and manipulation that we've been doing on the page. So required.js implemented this idea. So if I give it a script ID, it can unload it or undefine it, which is cool. I had a conversation with James Burke, who wrote required.js a few days ago, and he told me that unfortunately, although it is able to remove a single script, it's not able to handle scripts that have dependencies. So if I try to remove a script which has dependencies, it'll remove that one script, but it won't remove any of the dependencies. So it won't remove, so in the case of like a widget, which contains modules and collections and routers and all that stuff, it's not going to remove any of that stuff at all. So what I did instead was I created just some regular expressions that take care of this. I just pass in the exact same reference to my to-dos, and it'll then just go through required.js's caches and remove anything that it finds which falls under that exact same widget path. That's actually quite nice because it means that if other widgets are using dependencies which have been defined globally, like backbone or underscore, etc., you don't have to worry about those things being unloaded. Let me show you this in action. So I'm going to load up the developer tools. Now, let me get a reference to URL map. So this is required.js's internal cache of what it's actually loaded up. And as you can see, it contains all of Backbone Aura, jQuery, jQuery UI, underscore, the calendar widget. But the part that we're interested in first is the to-dos. Now, what happens when I stop to-dos is it's actually going to correctly unload this. It's going to remove all the DOM references, and it's also going to remove all the cached aspects of this from required.js. So let's do this again. And as you can see now, there are no more references to the to-dos in required.js's caches. So we've completely unloaded it. And something that I'm not going to demonstrate right now for time's sakes, but which you can try yourself later on, is you'll discover that when you unload modules in this, it will actually decrease the amount of memory being taken up by this particular tab. So what's next? Shim config. Required.js 2.0 also supports this idea of us no longer having to use patched versions of backbone.js and underscore.js. How many people here are still using those? The patched versions of AMD, AMD compatible versions? No? Okay, right. So basically, a while ago, the guy that created backbone.js and underscore.js decided that because it was interfering with some of the fixes he was trying to make, he would remove AMD compatibility from backbone and underscore. And for a few months, we had to continue using patched versions of those libraries if we wanted to use them with required.js. Now, with required.js 2.0, there's something called a shim config that we can use to get around this issue. So we no longer have to worry about using patched versions of any libraries. I can just go to the Backbone repo, pull in the latest version, and start using it. Now, how does that work? So if I go to my app.js, my configuration, all I'm doing is I'm passing in a shim object, which contains a reference to underscore.js as well as the exports that I want to export to the rest of my application to use from there. I'm doing the exact same thing with Backbone, so specifying its dependencies and what its exports are. I can then continue to use Backbone and pull it in the exact same way here, do the same for underscore here, or reverse the order if you want to load them up in the right order, but it'll just work, which I think is pretty cool. So the application core reacts to actions passed back from a sandbox, and we're going to go through the sandbox implementation in just a minute. And it also handles error detection and management. So what I'm doing is if there's an error in the application, I'm first going to check to make sure that there are no timeout errors, so we weren't perhaps able to load up the module because it couldn't find it on the server. But if there was an exception, I can then go use the new required.js 2.0 undef stuff to correctly unload that module so that it doesn't cause any other issues later on. Now, I'm not going to show you that, but let's talk about the sandbox. So we took a look at the facade pattern earlier on, and the sandbox is using that. It's basically an abstraction of the core that's an API for common tasks. Now, we're going to go back to the mediator for just a moment. I'm going to keep scrolling down. And our mediator is actually not just there to provide us pub sub. It's actually there to provide us core implementations of the utilities we're going to be using in our projects. So let's say that I want some DOM manipulation and I want the ability to select something on a page. Maybe today I'm happy using jQuery. So for my find, I'm just going to return something that's basically going to be using jQuery. And for data, I'm also going to alias to jQuery. But my application and any DOM references in it are now going to go through a facade and then go through this for DOM manipulation. If later on I decide, you know what, maybe this is a mobile project and I don't really care about using jQuery and I want to switch over to Zepto, or maybe I don't want to use jQuery or Zepto and I just want to switch to query select or all, you can just replace what find means and what find's implementation is right here and not have to change it anywhere else in your application, which is going to save you time. Similarly, with event handling, here we're basically saying we're going to be using jQuery for our listens and our bind all. You can switch that on. You can switch that to something completely different later on if you wanted. If you don't want to be using jQuery, switch it out for your own implementation or something completely different. Let's go to the facade. The facade is basically going to give us the API containing what we are really going to be using in the application. We're practically not going to need all of the utilities that the mediator is using to get everything done. And so we just expose what is needed. So we've got a subscribe, we've got a publish, we have a start, so we can start widgets, stop, so we can stop widgets. We've got the DOM, of course, event handling, and then other utilities. What we also have is an alias to templating. So if, for example, today I'm using handlebars.js or something else for my templating, and later on I want to change the alias to that to something else, I can easily do that through the mediator. We're working on an abstraction layer that will actually also take care of you not having to worry about syntax changes, but that's sort of further down in our timeline. At least with this, you get sort of the base functionality of how it would happen. Now, the facade isn't just there to give you a nice API. It's got this other little trick. It can keep your application a little more secure. And this is particularly useful if you're working in teams where people want to be able to develop widgets that perhaps also go on your page, and you don't want to give them the ability to do absolutely everything because people could fuck things up. So we have this idea of permissions in this architecture. And I'm able to validate any widget that tries to publish and get put on the page. Now, everything that I've shown you so far, the facade, the mediator, and the permission structure itself can all be extended. So we're going to go to an extensions folder now, where I'm able to extend the facade, I'm able to extend the mediator, and I'm able to extend my permissions. So my permissions here are very, very simple. All I'm saying is that there's a bootstrap attribute. And if bootstrap is set to true, you're able to render the widget to the page. If it's set to false, regardless of what you do, it won't. That's very, very basic. But you get this ability to basically define anything you want here. If you wanted to say, well, this widget is supposed to have access to our payment APIs, or this widget is supposed to have access to XHR, or so on and so forth, you could define all of those things here. And we plan on making our examples a little more complex to show you how to do these things. But let's take a look at the extension for the mediator. Now, for this particular demo, I wanted to extend the mediator to support working with Backbone. So I've created a namespace called MVC. Also, I'm not sure if anyone's read my articles on this stuff, but Backbone is actually the closest architectural framework to MVP that we currently have in the JavaScript community. So it fits in well with trying to go towards this decoupled direction of using things that work well in distributed teams. So mediator.mvc is basically aliasing to Backbone. I'm then also passing in a reference to local storage, so I can change this with something completely different if I wanted later on. I could replace it with store.js or amplify.js or whatever have you. In the facade, I'm then taking the MVC part that it's giving us. I'm saying, okay, well, you can actually create new views, new models, new collections. You can stop and start widgets from here. Now, when you're creating new views, I'm actually aliasing to Backbone's view.extend. Models, the same thing, and collections, the same thing as well. Now, whilst we haven't sort of demonstrated this just yet, this is going to possibly support the idea of you replacing what framework you're using in the future. So currently, we're using Backbone, but maybe if I re-aliased it to something like, I don't know, AngularJS, which has slightly different constructs, but the same concepts of models, etc., I could replace those capabilities with something pointing at Angular. You would have to deal with sort of syntax changes, but we're laying down the ground for how these things can be done. So I've gone through permissions, I've gone through the mediator, and I've gone through the facade. Let's take a very quick look at widgets. So as I've mentioned, widgets are essentially self-contained. They don't call each other. Ideally, they don't call each other. In the case of this particular application, I've made an exception. So let me reload this page. The part where you see start to-dos and stop to-dos and everything at the very end of the screen is actually a widget itself. And it's speaking to the other modules on the page, the other widgets on the page. Now, normally you wouldn't do that. Normally you would have your application using these capabilities, but I just wanted to show you how it worked just to get an idea. So every single widget is basically a wrapped collection of collections, models, templates, and what we're doing is rather than having our index contain any sort of markup for these things, this is the base for the widget, right? And then it has its own dynamic templates that it uses whenever you want to add new items, for example, to the to-dos list, and it's just going to use those. But in my view, all I'm doing in initialize is going and setting the HTML for a new widget to base.html. That allows me to basically go and create as many instances of this as I want. Right. So we've gone through the sandbox. We've gone through the fact that it's an interface for ensuring that modules don't directly access the core. We've gone through the idea of it handling permissions as well. Widgets, I think we've pointed out, are unique for your application. They can be easily started, easily stopped, and easily extended as well. And modules are unique blocks of code that can be loaded, unloaded, or easily reused. That's really it for Aura. But I'm hoping that it's the beginning of something exciting. I think that it takes care of a number of interesting challenges that we have to think about when we're developing applications that start to get larger and larger and slightly more complex. And when you start working in teams of people that have to be working on the same page and the same application, it factors in some of the concerns that you might have and tries to make sure that you're as effective as possible and as decoupled as possible. So I think decoupling is awesome. If you want to grab the code for this, it's available at bit.ly/backbone-aura. I'll also be tweeting this out to Web Rebels later on for anybody interested. Remember that coupling is bad and decoupling is awesome. And that's it. Thank you.
Okay, for once we're not ahead of schedule, so I'm afraid we're going to have to skip questions.
If anybody has any questions, please feel free to tweet me or ask me later on.
So, Christian, you're still here. I told him in the break that we had something special planned for him, and he looked ready to run for the hills. So.